Hello guys! Welcome sa aming YouTube video or sa YouTube channel namin. So, here, gumawa kami ng second method calculator na using C++ program. So, we are group secal or second method calculator, and then we'll be discussing kung yung about sa second method and then C++ program, and then diretso tayo sa application. Okay? Let's go.
Welcome to this presentation on the secant method, a powerful and widely used numerical technique for finding the roots of a function. If you've ever struggled to find where a function crosses the x-axis, this method offers an elegant and efficient solution. Before we dive in to the secant method itself, let's quickly recap what we mean by a root of a function. Simply put, a root is the value of x where the function f of x equals 0. Visually, it's where the graph of the function intersects the x-axis. So how does the secant method work? Unlike some other root finding methods that require the derivative of the function, the secant method relies purely on function evaluations. It uses two initial guesses to approximate the root by drawing a secant line between the corresponding points on the function's curve. The point where this secant line intersects the x-axis becomes our new and hopefully better approximations of the root. So let's look at the formula that governs the secant method. It might look a little intimidating at first, but we'll break it down step by step. Here, the x sub n plus 1 is our new approximation of the root. So x sub n and x sub n minus 1 are our two previous approximations, and f of x sub n and f of x sub n minus 1 are the function values at those points. Essentially, this formula calculates the x-intercept of the secant line passing through x sub n minus 1 and f of x sub n minus 1 and x sub n and functions of x sub n. So now let's walk through the secant method process step by step. So for the step 1, you have to choose two initial guesses. We begin by selecting two initial values. Let's call them the x sub 0 and x sub 1. These values should ideally be close to the root, but the method can still converge even with less accurate starting points. It's important that f of x sub 0 and f of x sub 1 are not equal. Next step is calculate the function values. You have to evaluate your function f of x at both of your initial guesses to find the f of x sub 0 and f of x sub 1. And next step is apply the secant formula. So you can find the next approximation. So using the formula we just discussed, you can calculate the x sub 2, where x sub 2 is equal to x sub 1 minus f of x sub 1 multiplied by f of x sub 1 minus f of x sub 0 multiplied by x sub 1 minus x sub 0. So this x sub 2 is where the secant line intersects the x-axis, giving us a new and improved estimate for the root. So for the step 4, you have to check for convergence. We need to determine if our current approximation is good enough. A common way to do this is to check if the absolute value of f of x sub 2 is less than a small predefined tolerance value, often denoted by epsilon. So if f of x sub 2 is less than epsilon, then x sub 2 is considered our root. And for the step 5, you iterate or either stop. If the convergence criterion is not met, We repeat the process. Our old x sub 1 becomes the new x sub n minus 1, or x sub 0 for the next iteration. And our newly calculated x sub 2 becomes our new x sub n, or x sub 1 for the next iteration. We then go back to step number 3 and continue iterating until the desired accuracy is achieved or a maximum number of iteration is reached. So, like any numerical method, the second method has its strengths and weaknesses. So, let's first talk about its advantages. So, second method doesn't require derivative. This is a major advantage over methods like Newton Raphson, especially when the derivative is difficult or impossible to calculate. Also, it is faster than bisection. Generally, it converges faster than the bisection method. Another advantages of second method is it is good for many functions. It works well for a wide range of functions. Beside those, it also have disadvantages. First is it requires two initial guesses, unlike some methods that only need one. Convergence not guaranteed. While often efficient, convergence is not guaranteed for all functions or all initial guesses. It can diverge if the function is highly nonlinear or if the initial guesses are poorly chosen. Also, its disadvantages is division by zero risk. So if f of x sub n minus f of x sub n minus 1 becomes 0, the method breaks down. This happens if two consecutive function values are equal, which implies a horizontal secant line. Now, let's visualize this with a quick example. So imagine we want to find the root of f of x is equal to x squared minus 2. We choose our initial guesses, draw our first secant line, find its x-intercept, and then repeat the process, getting closer and closer to the actual root, which in this case is 2. Notice how each new secant line brings us closer to the x-intercept of the function. So the second method is a valuable tool in numerical analysis, widely used in engineering, science, and economics for solving equations that cannot be solved analytically. Its simplicity and efficiency make it a popular choice for approximating roots. So that's it. We hope this presentation has given you a clear understanding of the second method. Thank you.
What is a C++ program? A C++ program is a set of instructions written in the C++ programming language. This typically includes functions, variables, and control structures to perform a specific task. C++ is a powerful, high-performance language commonly used in system or software development, game programming, real-time simulations, and scientific computing. We use C++ for the second method because of its efficiency, precision, and control, especially in educational and engineering applications. It gives insights into how roots finding works numerically, and it has a strong foundation for more advanced methods or solving real-world equations.
So thank you, Julius, for the C++ program. So let's continue the scope and the limitation. So this project focuses on applying the second method specifically to solve polynomial equations with real coefficients. So this program obtains the root of a polynomial with third to the 10th degree. So hanggang dun lang, hanggang 3 to 10 ang yung range. Di pwede mabawas sa 3 or di pwede sumobra sa 10. No? So the project does not include comparisons with other roots finding methods, nor does it handle functions beyond polynomials or those with complex roots. So the accuracy of the method may also be affected by poor initial guesses, which is known limitation of the second method itself. So yun yung limit ng aming project. So we're done with the scope and the limitation. Let's proceed to the sample problem. So here's the sample problem. Solve a root x1 of a function fx equals to x cubed plus 5x squared plus 7x minus 20, where the initial values xo is equals to 1 and x1 is equals to 2. So using a second method in a C++ program. So but before that na i-answer yung problem, tignan muna natin yung mga code sa C++. So here, we use the developer C++ application. So check the link below, dun namin nakuha yung application. So again, let's continue. So ito na yung code namin. Kasabay na rin to, send ko na rin to dito sa description below. So try natin i-answer yun. So let's run this program. Pero syempre, laging i-compile and after compile, then run. Or sabay nga, compile and run. Okay? So here we have. So, the function was, the degree of the function was 3. Okay, x cubed was it. And then 1x cubed, that's 1. And then we have 5x squared. And then 7x minus 20. That's negative 20. So, enter the precision decimal points. So, let's just say hanggang 4 lang. And then, enter the required accuracy. So, about 0.0001. Yan. So, enter the initial values. So, ang x1 natin, di ba, is 1. And then, ang x2 naman natin is 2. So, the answer ay hanggang, therefore, after 5 iteration, the roots x2 is 1, or x1 pala, namali ako dito, na mali yung input, pero x1, the roots x1 is 1.3101. So thank you for using SecCalculator created by the group SecCalculator, BSM 2A Students 2025. So tignan natin kung tama yung ating sagot. So checking. Okay, so here's the answer. We have 1.310. So tama ang ating sagot. So itong sagot na to is galing sa aming instructor. Thank you Sir Jazz for the answer and in the problem. So we have the 1.310. This is manually answered by our instructor. So paano naman nga JJ kapag yun yan, yung sinabi mo, negative 3, mas bababa pa sa 3 or sobra pa sa 10. Check natin. Sabihin naman natin na 2. Sabihin naman natin na 2 or yan. So the degree you entered is out of range. Kahit bumaba pa yan sa from 1, 2, 1, negative 0, ay negative 1, negative 2, etc. Kahit naman, ito. Kahit naman na 11, di ba? More than 10. The degree you entered is out of range. Ganun rin, kahit sumubra pa yan. So yun, that's it for our program. I hope you guys may natutunan po kayo sa aming project. And again, sana makatulong to sa inyo. And thank you for watching. And please subscribe and comment down below kung meron kayong thoughts and kung meron kayong opinion na makakapagtulong po sa bawat isa. Thank you and bye-bye.